We're going to talk about proportional reasoning in section 2.2. A lot of this should hopefully be a review for you. We'll also have some newer parts, maybe some tougher parts. But proportions themselves should be reviewed. All right, so proportional reasoning today, section 2.2. Vocabulary here, first couple things. First off, we're going to start off talking about a ratio. A ratio is a comparison of two quantities by division. There are three ways to write a ratio. The first one is you can use a fraction. So I can write it as like 1/2. Okay, so 1/2 or a fraction there. Or you can write it with a colon. So 1:2. Write it as 1 to 2. Or you can use it as words 1 to 2. Okay, so again, the last ones are all red, still 1 to 2. But yeah, ratios is just a comparison of two quantities by division. Alright, proportion. A proportion is a statement that two ratios are equal. Proportion states they are equal. So for example here I have 2/3 equals 4/6. That is a true statement. 2/3 is the same thing as 4/6. What if I gave you the fraction, let's say 1/2. What's another ratio that is the same as 1/2? 2/4. Okay, now I just made a proportion. So I made a ratio and a proportion by stating they're equal. A rate. A rate is a ratio that compares two quantities measured in different units. What is a rate you see on a daily basis, probably on your way to school or on your way home from school, if you were to drive? Miles per hour. Yeah, if you look down at your gauge and you see miles per hour, guess what? Miles is one rate, hours is another rate. That is a rate. Okay, so miles per hour would be a rate. Hey, look, guess what? That's the definition they give you. What's another rate that you see on a regular basis? A lot of times associated with cars. Cars have a ton of rates. Anybody? RPMs, revolutions per minute. RPMs are another rate. When anybody fills up their gas tank, do they ever look at their miles per gallon?
I can't even figure that out. Oh.
Take the number of miles you got per gallon?
No, don't you or how many gallons?
No, you take how many miles you've driven since the last fill up and divide it by how many gallons you just put into your car.
That's it? I'm gonna figure it out.
Miles per gallon, yeah, there's another rate. Okay, all those are different types of rates. Similar. Two figures are similar if they have the same shape but not necessarily the same size. There are two shapes that are always similar. Do you know the name of the two shapes that are always similar?
Circle.
And?
Square.
Square. Circles and squares are always going to be similar. Okay? Rectangles, as we know, you can have like a really fat rectangle or a really skinny rectangle. Okay? Triangles can have all different shapes and sizes there. But circles and squares are always going to be similar. Okay? And then indirect measurement, this is what we're going to talk a lot today about. Indirect measurement is a method of measurement that uses formulas, similar figures, and proportions. We're going to talk about using similar figures and proportions today. Alright, so first thing we're going to talk about is solving proportions. Now, as you know, what's the process called to solve proportions? It is known as cross products. Very good. It is on the poster over there. Okay? But yeah, we're going to use cross products to solve proportions. So cross products is multiplying the diagonals there and then solving. Okay, so here's kind of the process to solve. I can use proportions or cross products to solve when I have a percent as well. Who knows what a percent means? What's a percent mean? Percent is out of what always? 100. So when I have a percent, I can write it as percent out of 100, and I can set up a proportion and use cross products to solve. Okay? So let's look at number one here. I have 1/7 equals x over 56.
8.
Now, Chow thinks it's 8, and it is 8. Chow, how'd you figure that out so fast? Well, he said cross products. So we did 1 times 56, right? Equals 7 times x, right? Divide them both by 7. 56 divided by 7, I get x equals 8. Now, what else can I use? Proportions are nothing more than equivalent what? Fractions, right? Does everybody see the fraction here, 1/7? Okay, if they're equivalent fractions, 7 times what is 56? So 1 times 8 is going to be what? Hey, guess what? I got the same answer there. So when you have equivalent fractions that you can see mentally, you can actually work that out a little bit easier. 2 now, no equivalent fractions on 2. I don't have to actually set this up. So cross product says I'm going to do 25 times x. So I get 25x equals 20 times 60. That's 1200. I want to divide both sides by 25.
I hope we can use a calculator for this, because there's no chance I'm doing all that.
1200 divided by 25, it actually comes out to be 48.
What house
Nice job. There are some that you'll probably need a calculator on. There's some decimals and things. All right, 3. Now here's the key to problem like 3. This is different. I have x plus 3 over 12 equals 7 over 2. Cross products, right? Does everybody see the 2? I got to take the 2 times the x plus 3. So what? I'm going to have to do what? Somebody said it? I'm going to have to distribute the 2. So that's really going to give me 2x plus 6 equals 7 times 12 is 84. Notice, I take the 2 times the x and the 2 times the 3. I got to do both of them. Now I can solve, subtract the 6. 2x equals 78, divide by 2. X comes out to equal 39. Okay? Again, understanding that you have to distribute on a problem like that is key. Number 4. Story problems throw a lot of students off. Here's why. The ratio of boys to girls in a soccer league is 4 to 5. Notice, boys to girls, 4 to 5. Who can tell me why they said boys to girls and 4 to 5? How do I know what the 4 goes with and what the 5 goes with? Order, right? They said boys to girls. So what's that 4 associated with, the boys or the girls? Yeah. Boys to girls is 4 to 5. So that means there's 4 boys for every 5 girls. If there are 52 boys in the league, how many girls are there? I need to set a proportion up. The biggest thing when setting story problems up is you have to be consistent. Consistent how you set it up. What that means is if I have boys to girls, for example, let's say I do boys over girls, because I want to write it as a fraction. Well, throughout the whole problem, I need to make sure I do boys on top, girls on the bottom. So that means I would do 4 over 5 equals 52 over x. And now I can solve it. Okay? Now I use cross products to solve. When I do that, I get x equals what? 60 what? 65. So there are 65 girls then in there. Alright? Again, the biggest thing is being consistent how to set that up.
Can you leave that up for a minute?
Yeah, you bet. Alright, take a couple seconds, try these 3 on your own. Same idea. Use cross products and proportions to solve these 3. Alright, number 5. Use cross products. 10 times x equals 10x. 6 times 250 is... Or 6 times 25 is what? Divide by 10. I get x equals 15. Now pay attention to number 6 here. I got to take 10 times x plus 2. So I get 10x plus 20 equals 14 times x, so I get 14x. Recognize now, which do I have to move here? Do I move the constant or the variable? I got to move the variable here. So I get 20 equals 4x. I end up with x equals 5. Now again, if I were to plug that in, would that make sense? Well, that would say 7 over 14 equals 5 over 10. Yeah, that makes sense. All right, and 7. A slug travels 4.5 inches in 120 minutes. Well, that's inches, minutes. So I'm going to say 4.5 over 120 equals, at this rate of speed, how long would it take the slug to travel 12 inches? Is the 12 going to be in the numerator or denominator of my other fraction? Numerator. Why? Because I already have inches on top, so it's 12 over x. Now I use cross products and solve. Drew, what do I get for number 7? Beast? It is 320 minutes. Does anybody know how many hours that'd be? 320 minutes?
Approximately 3.
Wait. No.
320 minutes. How many hours is that?
3 hours and 20 minutes. 5 hours and 5 hours and 1/3.
5 hours and 1/3, or 5 hours and 20 minutes.
Yeah.
Here we go. Last thing we're talking about today is applying proportions. All right, we can apply proportions here to story problems. So, for example, a proportion can be used to solve problems with problems about indirect measurement. Jake is 6 feet tall and casts a shadow 15 feet long. Okay. At the same time, a tree casts a shadow 50 feet long. For instance, we don't have the capability sometimes to measure really tall objects. So what do we use? We use indirect measurement, and we can get an approximate height there. All right. Again, because it's easier to find my height and my shadow than it is to find the actual height of a bigger object. Okay, so here's what it is. The objects and their shadows form similar triangles. Okay, what I always tell students to do is be consistent, right? I am always a person that does height over shadow. Why do I do height over shadow? Because it makes a proportion already. Height over shadow equals height over shadow. I have already fractions set up. Okay, so for instance, I would do 6 over 15 equals h over 50. Now I use cross products and I can solve the height, the tree is about 20 feet tall. Again, it's easier to do this than it is to scale a tree and try and find the height that way. Okay, so for instance here, number 8. A tree casts a shadow of 7.5 feet long. Now, I'm going to go all Bob Ross here on you guys. Does anybody know who Bob Ross is?
I'm not sure what that means.
You guys don't know who Bob Ross is? Happy Trees?
Yeah.
Never heard of Bob Ross?
Is that the art show where it's like really boring and he just paints like nature scenes the entire time?
Who? Yeah, these are nature scenes. Bob Ross. Bob Ross is a famous painter. Okay, he used to have his own channel. He just sit there and paint, and he always talk about happy trees.
It was really
Classic.
Really quiet and chill.
So I got a tree here. The tree casts shadow 7.5 feet. Okay, so there's 7.5 feet. I don't know the height of the tree, so there's X. I have a woman over here. There we go. The woman's 5 feet tall. She casts a shadow of 3 feet long. I want to set a proportion up here. Recognize they're already set up. I can draw lines right through here. Guess what? My proportions are set up. I want to do height over shadow. So I'm going to say x over 7.5 equals 5 over 3. Again, x over 7.5 equals 5 over 3. I have the proportions set up. Now I can use cross products to solve this. I would do 5 times 7.5, which is, what's that, 37.5? Equals 3 times x is 3x. Divide by 3. And I get x to come out and be, what is it? Is it 12.5? Right? Yeah. X equals 12.5 feet. Again, biggest thing there is setting the proportions up, drawing a diagram, being consistent. If you don't set it up consistently, you're going to make mistakes. All right, take a couple seconds to try these two on your own. All right, let's look at number 9 here. Now again, I want to draw a tree. I starts off with a tree. Tree has a 26-foot shadow, so there's 26. Boy standing nearby. Boy's got a 4.5 shadow, or sorry, boy's got a 12-foot shadow. The boy is 4.5 feet tall. How tall is the tree? Recognize, I draw my lines through. Guess what? My proportions are set up already. X over 26 equals 4.5 over 12. Both of them have height over shadow. I use cross products, set it up. Allie, what do you get for an answer now?
9.75.
Yeah, X equals 9.75 feet. Good work. 10, I have a house. Okay, there's my house. House casts a 56-foot shadow. A girl standing nearby. Okay, casts a 7.2-foot shadow. Her height is 5.4 feet. What is the height of the house? Again, draw my diagram out. I can throw my lines in. I have my proportions set up. X over 56 equals 5.4 over 7.2. And I worked that one out. What do I get for the answer there, Beast? 42 feet. Nice job. Again, you got to be consistent how you set it up. Height over shadow equals height over shadow. Consistency is key. All right. I can also use this for road maps. Has everybody seen like a road map before, right? in the bottom corner is always a scale, isn't there? Like an inch equals so many miles or so many kilometers, okay? Well, on this scale, it says a road map is 1 inch equals 10 miles. You want to find out how far Waterloo and Lincoln are. On the map, they are 5 inches. How many miles are they apart? Well, I have 1 inch equals 10 miles, right? So that's like saying 1 over 10 equals 5 over x. And now I can use cross products and solve. I think we all figured out, what is it? 50 miles. Okay? Again, cross products helps you solve these. Try these 2 on your own. Same idea. Sorry, yeah, try number 12 on your own. So yeah, I'd use the same scale here. I'd say, oops, back 1. I'd say 1 over 10 equals 2.5 over x. Cross product solve. Allie, what'd you get? 25 miles. Nice job. All right, here's your assignment.